We've been dreaming about going to Mars for decades, right? But the trip itself, that's always been the massive roadblock. So what if we could crush that journey down from almost a year to just a couple of months? Today, we're going to dig into a plan that could do exactly that, all thanks to a seriously revolutionary new engine. So to really get why speed is so critical here, we've got to ask, what is the single biggest threat that astronauts face on that long, lonely trip between planets? Well, it really boils down to two major enemies out there in deep space: radiation and time. See, once you leave the safety of Earth's protective magnetic field, our astronauts get blasted by cosmic rays and solar particles. That really ups their risk for all sorts of health problems. And of course, the longer the trip, the more radiation they soak up. And with the kind of chemical rockets we use now, that is a long, long trip. I mean, we're talking a grueling 6 to 9 months, one way. That is a huge amount of time to be exposed to radiation, not to mention all the negative effects of living in zero-G. Okay, but what if we could just slash that? Cut that travel time down to just 64 days, a little over 2 months. That's the absolute game changer we're looking at today, and it's all made possible by a radical new way to power a spaceship. All right, so how on Earth is that even possible? Well, it all comes down to a completely new kind of engine, the Starfire direct fusion drive. So this thing was developed by a company called Princeton Satellite Systems, and the direct fusion drive, or DFD, is basically a compact nuclear fusion reactor. What's so clever about it is that it's a 2-for-1 deal. On the way to Mars, it's this super efficient engine, but once you get there, you can flip a switch and it becomes a long-term power plant for your Martian base. Now, when I say fusion reactor, you're probably picturing one of those giant donut-shaped machines called a tokamak, like the one on the right. But the Starfire reactor is totally different. It uses a design called a field-reversed configuration, and as you can see, it's tube-shaped and way, way smaller. It also uses a cleaner fuel that produces fewer nasty neutrons, which is a huge deal because it means you don't need nearly as much heavy shielding, perfect for a spacecraft. And get this, the efficiency numbers are just mind-blowing. As Layla Mohsen from the company points out, this design has an incredible power-to-weight ratio. That right there, that's the secret sauce that makes this whole fast travel thing work. This chart really puts it all into perspective. Okay, so specific impulse. Just think of it like miles per gallon for a rocket. A really good chemical rocket might get you around 500 seconds. The direct fusion drive? It's aiming for 20,000. I mean, that's not just an improvement, that's a whole different ballgame. Okay, so you've got this amazing new engine. You can't just slap it on an old mission plan, right? You need a whole new strategy. And this one is built around a really smart two-ship approach that's all about being safe and fast. So check this out. Here's the plan. First, way ahead of time, like 3 years before the astronauts even pack their bags, they launch a slow, heavy cargo ship. It's got everything: the power plant, robots, all the supplies. Once it gets to Mars, the robots spend about a year building an underground base. Only then, when everything is ready, does the super lightweight cruise ship launch for that quick 64-day sprint, knowing their new home is waiting for them. This timeline makes it super clear, right? The cargo ship is like the advance team. It does all the hard work years before humans show up. The crew doesn't even leave Earth until their new home on Mars is completely built, tested, and ready to go. Move-in ready. So, picture this. The crew lands. They made it, safe and sound, and in record time. So, what now? What's life actually going to be like on Mars with this kind of setup? Of course, you still gotta land the thing, and that's always tricky. But they're not reinventing the wheel here. The plan is based on NASA's super successful Viking missions, using a combination of a heat shield, parachutes, and then thrusters for that final, gentle touchdown. And this is what they'll call home. The living quarters are underground, which gives them the best possible protection from radiation. The whole place is powered by that Starfire reactor, and they even have a sustainable garden, which is awesome, not just for fresh food, but you can imagine how good that would be for morale after months in space. The whole base is set up for a 2-year stay, really letting them live off the land. Okay, but what about getting back? How do you fuel up for the return trip? Get this. Using the base's fusion reactor and water ice found on Mars, it would take only 10 days to make all the rocket fuel they need to get back up into orbit. And this quote, it just says it all, doesn't it? This whole idea isn't just about a quick visit, planting a flag and heading home. The goal is to build something that can last, something self-sufficient, so we can establish a real, permanent human presence on another planet. Now, going to Mars is obviously the big, flashy headline here. But the potential for this technology is way bigger than just space travel. It could be a game changer right here on Earth. I mean, think about it. You could use this same little reactor to bring power to really remote places on Earth. Or the military could use it in ships and submarines instead of traditional fission reactors. So yeah, it's an incredibly versatile piece of technology with uses far beyond just exploring the solar system. All right, so let's just quickly run through the big takeaways here. First, a 2-month trip to Mars isn't science fiction anymore. Fusion makes it possible. Second, the key piece of tech is that compact, tube-shaped direct fusion drive. And finally, this isn't just about getting there. It's about staying there sustainably. And the tech could have huge benefits for us back on Earth, too. And that really leaves us with one big, exciting question. For all of human history, we've been stuck in our own little corner of the solar system. But if we can crack this, if we can really get to Mars in just 2 months, it makes you wonder, doesn't it? Where do we go next?